the 3 and the 2 to get 24. And then we add the exponents. So it becomes x to the 5th, it becomes y to the 4th. So it would be letter J. For number 14, this is n to the 7th times n to the 7th times n to the 7th times n to the 7th, 11 different times. So you're going to add up 7 11 times. If you add up 7 11 times, it's the same as 7 times 11, which is n to the 77th. And if you take two things and divide them, come up with n squared, that would be, for example, like n to the 8th divided by n to the 6th, or n to the 3rd divided by n to the 1st. As long as the top one is 2 more than the bottom, then you get n squared. So that means you subtract the exponents. So in this unit, we are beginning to look at what happens when we deal with x that's not to the first power. So the last unit was x to the first power. What do we do? Well, in this situation, if you have the same bases, and notice that a is the same, then you add the exponents. It becomes x plus a to the x plus y. So what that looks like in a real example would be, say, b to the 3rd times b to the 5th. And that would make b to the 8th. The next one, do you remember from our exercise, what did you do if you had a power to a power? Yeah, a to the m times n. So for example, if you had x to the 3rd and you're going to take that to the 5th power, that would be x to the 15th power. That's what that means. And finally, if you're dividing them, you subtract them, so s minus r. So for example, if you had x to the 12th divided by x to the 5th, that would produce x to the 7th. So we're not going to spend too much time with the dividing today. We're going to look at the multiplying. I'll do a couple, and then you can do a couple. But notice here we have coefficients out front. When you have coefficients, you just multiply them. But you don't multiply the exponents here, you add the exponents. So it's x to the 7th. The next one is 2 times 9 is 18. And then we add the exponents for x to get 8, and we add the exponents for y to get 7. Why don't you try number 3 and 4 on your own? Is that right? Yeah. Feel good? So here's the confusion where people make mistakes. They see this and they're like, well, do I have to multiply by that one and multiply by this one? And you don't, because these are all being multiplied together. This is actually one single unit. It's one single term. We're just writing a more simplified way. Whereas this, we are actually taking 4x squared and we're multiplying two different terms. Okay, two different terms. So we're distributing multiplication over addition or subtraction. That's when you extend beyond. And so we get 12x to the 7th minus 24x to the 6th. Go ahead and do number 6 on your own.
You don't multiply when it's like that, when you factor.
Nope. Multiply,
you only multiply when it's
like a power to a power. Yep, like when we get to number 7. good? Okay. I want to go off of what Bella was referencing because I think it's an important question to be asked, and I think that this is a kind of a chart. I don't know. Sometimes I take chances. Sometimes I do things that help people, and sometimes they don't help people. So you guys tell me one way or the other. Okay. So suppose I had you don't have to write this down. Suppose I had 2x to the 6th, and I was going to cube it. Okay. I think of things this way. I think of powers. I think of multiplication. I think of addition. And I think of nothing. Okay? And so I ask myself, okay, what is the operation here? Okay? And the operation is a power, right? So what I do to the exponent is exactly that. I take it to the power. What is 2 to the 3rd? What does that mean?
2 times 2.
And what is 2 times 2 times 2? 8. So the coefficient, I always do the operation. But when you get to the exponent, you do one thing down. See what I'm saying? So like in this situation, it's then x to the 6 to the 3rd. So since the operation is power to the exponent, I do one thing less. So I multiply to get x to the 18th. Suppose in this situation, you did 2x to the 6th times 5x to the 3rd. The operation is multiplication, isn't it? So we multiply the 2 and the 5. But what do we do the exponents? We do one step down. We add them, and we get x to the 9th. See that? So the operation for the exponents is always one less than what you would do otherwise. Now you're like, well, what'd that nothing thing look like? I'll show you. There's a perfect example. Suppose I had 2x to the 4th plus 5x to the 4th. Well, my operation is addition. So I take the 2 plus the 5 to get the 7, and then I do nothing to the exponent. It just stays to the 4th. That's combining like terms. See how the exponents is always one step down? Just take it. Should I stand by it?
Mm-hmm.
Oh. You get the idea? Mm-hmm. Exponents is always one step down. That's how I like to think of it. So I don't know if that works for you, but so anyway, we finish off with these. Are we out of time?
Yeah, no.
Oh, we got a couple minutes. We can finish this off. So what do I do there? To get x to the 12th. Okay. Whereas in this situation, I start with 2 to the 3rd. As you guys just said, 2 to the 3rd is 8. And then I multiply the exponents to get 6 and 15. Number 9, negative 3 to the 4th power. Negative 3 times negative 3 times negative 3. Negative 27 times negative 3. 81. So I did the power to the coefficient, but what do I do to my exponents? Multiply. And I get 12, 4, and 20. Try number 10 on your own. Very good with that? Okay, then on Monday we'll pick up with 11 to 12 on the backside. Thanks for having fun with my taboo game today. These 5-day weeks, gotta break them up a little bit. Did you guys know they have a 5-day week next week, but then after that you get the next Monday off?
Why?
Did you know you get the Monday off after homecoming?
Why? Wait.
We need to sit around as teachers and figure out how to become better teachers or something, I guess. So
Heck yeah.
you guys
That is
get the
such
day
a
off.
score.
Sounds like an excuse to party
Guys, you
Sunday.
need a week to do
Yeah. What's that?
that? You need a week to do that?
Oh, I would agree. We should probably take a whole month to do that.
Yeah. Maybe we just start back up next year.
We could do that too. Delay you guys a year.
Yeah.
To stay in high school forever.
I get Sunday off then.
Got a game on two rest.
Here?
I don't know yet. And then on Monday we have a game at Red Wing, and then Tuesday we have a game here.
You gotta go to Red Wing.
Games on a road. Sundays are one day off.
Chili is so cold.
No,
You think you can walk
I
over
think
it?
I want
Someone
to
jumped it
shift.
last year. Yeah. It looks like you walk over it. It kind of looks like you can walk over it. Yeah, pretty much. Oh, you get so tangled up. Oh, yeah. I feel like that pile just straight bottom to bottom. It probably is. Let's test it out. And fall, you're like falling too bad after everything it dies off.
Is this not like a bleach thing?
I'm not testing
I-
it. Is that what it is?
It's a guy's.
Unless like,
But, like,
we get money on it or
but,
something.
like, I was like, everyone's
A
like,
decent
these
amount.
things don't happen. I'm like, bro,
I didn't realize though.
More than $10. Hey.
because I mean,
Anything
it's like
you
a
do
so
for $10?
Ford, what the heck? Everyone keeps thinking it's bleach.
Oh, okay.
I mean, I can see it too. But
It's like when you're far away, you like.
Here we go. Yeah, we're going. Everyone go.
I just praised him for being so good. Now I have to love him. Thank you. I love it. How many did he give away?